Okay, we're all familiar with functions, right? We can have a function like a parabola. Uh, how about a hyperbola? We can have an hyperbola as well. It should look something like this. Sorry about that. A hyperbola will look something like this. So we're going to have the asymptotes there, stuff like that. We can also have a linear function. We can also have like some sort of a cubic function. And then we can have like an exponential function. What else? We can also have a logarithmic function. So whenever like you look at this kind of stuff, this is just a single function if you look at it. But what if I told you that you can combine this function and form a new function from that? So let's say that we have a certain parabola on a certain domain. And then from then, after that, we have like a straight line function from there. And then from then, we can have like some sort of a, let's say, an exponential function, something like this. Notice something. You have a parabola, link that with a straight line, link that with an exponential function. So this is just a single function. We can call this whole function g at x, and g at x consists of functions, certain functions, and here it's given by a parabola on a certain region. So we have region 1. We can just say maybe it's given by x squared, and then we can predict the region and say that maybe x is just less than 1, and that's when we define g at x as we define g at x as x squared. And then we can proceed, we can go on ahead and say, oh, well, we can set it equals to x for x between 1 and 4. And then we can go ahead and say it's an exponential function. Let's say maybe we have half to the power of x. Then we have a value outside, let's see, 4. Plug in 4 here, you have 1 over 16, 16. Let's say maybe you have 64 like that. 64, if you plug in 4 here, we have 1 over 16, then we get 4. Yeah, so where x is greater than 4. So these three things are called subfunctions. These ones, they are subfunctions, and they form a bigger function here. And this function, we call it a piecewise function. It consists of subfunctions. So this is just the idea of what's happening here. A piecewise function consists of subfunctions. All right. Okay. So can you sketch a piecewise function? Can you find the domain of a piecewise function? How about the range of a piecewise function? Okay, we're gonna get to that. So let's say maybe we have g at x. G at x given by let's say maybe we have x plus 2, where x is less than 0, and then it's given by x squared, where x is between 0 and 2, and 2 is included in this region. And then let's say it's given by x minus 2 for, okay, or let's say minus x minus 2 for x between 2 and 4, strictly less than 4, or let's include 4. So let's say we have a piecewise function given by this. What is the domain of this piecewise function? How do you find the domain of this piecewise function? Okay, so the easier way to do this is draw a number line, okay? And then plot these numbers that you find in this values in the subfunction's domain. So let's see, I see 0 here. So you're going to put 0 on that number line. I see 0 here, and I also see 2. 2 is on the right of 0. And then you see this is 2, it's already on the number line, and we also see 4. Okay, so let's see. X is less than 0. Any value less than 0 is on the side of a number line. On the side of a number line. And keep in mind, 0 is not included, right? Okay, so we can just shade the region, this one. We can just shade this region. Okay, and then we see an interval between 0 and 2 as well. And 2 is included. You see that 2 is included? Okay, so we shade in 2 because 2 is included here. And we are in the region between 0 and 2. We're in the region between 0 and 2. And here, we're in the region between 2 and 4. And 4 is included, so we're going to shade 4. We're in the region between that. And then we don't have anything greater than 4. See something? This whole thing will be the domain of g at x. Listen to me. This whole thing, when you map this interval, that will be the domain of the piecewise function provided. Okay, so we see less than 0, and 0 is not included. So x, the domain of that g at x, will be x is an element of, let's see, you plug in, it's all negative numbers. Less than 0 just means all negative numbers. And then 0 is not included, so you're going to have a small bracket. Intersection 0, and we also have a second region between 0 and 2, and 0 is not included, so we're going to go ahead and do this, and 2 is included, so we're going to have this. And then intersection 2 and 4, between the region between 2 and 4, and both of them are included, so we're going to have 2 and 4. But then this is just bull nuggets, okay? Because you can't do this, because this is just the same region. This is continuous up until that region, so that's where you have to be careful. We only we only include the intersection if we do not have we only include intersection if we have like a hole here, or a restricted region, or a gap in the region. So the domain will just be something like this: minus infinity to 0, union 0 to 4. This just covers up the whole thing. You don't need to write the domains like this. We are mathematicians. Keep everything as short and concise as possible. So this will be the domain of our piecewise function. Now, how do we find the range? Well, it's easier to just graph this. It's easier to just graph this, and then we can find the range of this. Okay, let's try and graph this piecewise function. Okay, so let's see. For x less than 0, we define our function as x plus 2. So this is 0 here. We expect to have 0 here. And for less than 0, we define our function as x plus 2. So if we plug in 0 here, we get 2. So we expect 2 to lie somewhere there. And we're going to have an open region here. That's because we don't have an equal sign for where x is 0. And then we have 2 there. Here it's where y equals 2. Because if you plug in 0 here, we get 2, right? Okay. Now, for less than 0, we can plug in minus 1. And when we plug in minus 1 here, we get 1. So this graph just going to slope downwards like this. And we will plug in minus 2, and you're just going to have 0. And it continues like that. So you're going to have a linear function. You're going to have a linear function going that way. Straight line function, continuous on the negative region of that. And it's discontinuous at 2. So this is where we get minus 2. So that's the first region. Check. You graph the first region, then it's a check. And then we go for the second region. This one it's a parabola between the region 0 and 2. Notice again 0 is excluded. If you plug in 0 here, you get 0. 0 squared 0. So remember, it's also, we don't have an equal sign here, so it's excluded as well. So we have a hole here. And then it's a parabola, right? So you plug in 2, you get 4. You plug in 2, you get 4. You expect the y value of 4 to be somewhere there. And we expect 2 to be somewhere here, right? So it's a parabola. So it's just gonna go and be something like this. It's gonna go and be something like this. And remember, 2 is included, so that means that we're gonna have something like this. It's included. This region is included, so 4 is included. 4 is in the range. Okay. And then let's proceed ahead. So we sketch the second region, check, and then we go ahead and sketch minus x minus 2. Minus x minus 2. So this is between 2 and 4. If you plug in 2 here, you get what? And remember, 2 is excluded, right? You get minus 2 minus 2, and you get minus 4. Minus 4, let's predict that minus 4 is somewhere here. I don't have space, but let's just guess it's right. So I guess minus 4 will be somewhere there. And then you're going to plug in the next value, which is minus 3. Which is 3. You plug in 3, that's just going to slope downward. So we have a linear function from here going downward up until 4. Going downward up until 4. I don't have space here, né? So, and remember, 4 is included. And then you plug in 4 here, you get minus 6. So you have minus 6. And then it's included, so you're going to have something like this. So that will be your function, g at x. So what's the range? What's the range of this? This just continues in this interval, going down straight. You can see that this part here, this negative part here, accounts for every negative value of the function. And at 2, we also have a part of a function that's equals to 2, going upward up until 4. We have every negative y value of the function until 2 is here. 2 is also in the range because this part can be equals to 2. And then it goes upward like this. When I mean this part can be equals to 2, if you substitute in root 2 into this function, root 2 is between 0 and 2, so you substitute here, you get 2. So 2 is in the range. So that means we have every negative value. 2 is here. It's excluded here, but it's here. And 0 is here. It's excluded here, but 0 is here in the range. Okay, and then we go up until 4. 4 is the peak value of this. So the range of this one becomes y is the element of every negative value up until a positive maximum value of 4. So that will be the range of that piecewise function. I'm going to do more examples of piecewise functions, but I'd like to know the ideas you have on what I should cover in my next work. Thanks for watching. Don't forget to share and subscribe.